It's a video for AQA Further Pure Mathematics, Algebra and Graphs, section 2.3, where we're looking at cubic and quartic inequalities. Well, cubic and quartic inequalities, in other words, ones involving polynomials x cubed or x to the power 4, solved using exactly the same methods as we've already met in previous videos. If f of x is factorised, then we have the roots of the equation f of x equal to 0, and they can be found easily and a graph of y equals f of x sketched. There's one thing to remember with this approach is that if we have a repeated root, then the graph will just touch the x-axis so that the sign of f of x doesn't change at that point. So let's just look at an example of this then. Here we've got a graph, or we've got an inequality rather, which says that f of x is less than or equal to 0 for f of x is equal to 2x to the power 4 minus x cubed minus 5x squared plus x plus 3. We can use the factor theorem and show that f of 1 and f of negative 1 are both equal to 0. And therefore we have got roots, or factors rather, f x minus 1 and x plus 1. These form a quadratic factor x squared minus 1. So we've got the difference of two squares there. So therefore f of x can be written as x minus 1, x plus 1 multiplied by some quadratic factor, which is x squared minus 1 multiplied by a quadratic. Now we can get the quadratic factor by inspection, because we can see that the quartic term, the x to the power 4, is 2. So therefore we can say that f of x must be equal to x squared minus 1 multiplied by 2x squared. That's the x squared term. We see that the number term is plus 3. We've got minus 1 in our x squared minus 1, so therefore it must be minus 3 at the end of this quadratic. And so we can get the other term by inspection of one of the other powers. So for example, if we look at the x cubed power, x cubed comes from the x squared multiplied by this x here, and the 2x squared multiplied by the x power in here, which is 0. So we've got 0x cubed from there. So therefore this must be minus 1x cubed or in other words, the x term must be minus x. Now once we've got that, we've got another quadratic which factorizes. And in fact, if we look at the factors of that one, we have got 2x minus 3 and x plus 1. So in total, f of x is equal to x minus 1, x plus 1 from our factor theorem work, and then 2x minus 3 and x plus 1 from the other quadratic. So that we've got x minus 1, 2x minus 3 and x plus 1 all squared. So we've got a repeated root there at x equals minus 1, so the roots are x is equal to negative 1, x is equal to plus 1, and x is equal to 3 over 2. And this one here is repeated. So what we've got so far then is our function f of x factorized. Now we can sketch a graph. Because we've got a repeated root, it's going to touch the axis at negative 1, and then we'll cross the axis at plus 1 and 3 over 2. It's a quartic equation, so it has the standard shape of x to the power 4, and we can see it looks like this. And so we've got that repeated root at -1, crossing the axis at 1 and 3 over 2. We now want to look at when f of x is less than or equal to 0, so we can see we've got that one point there where it's equal to 0, and then between the values 1 and 3 over 2, where it's less than or equal to 0. Well, that completes this video on cubic and quartic equations. So you see that the methods are exactly the same as in the previous videos. In fact, that indeed concludes the section on algebra and graphs.